Good morning everybody. Today we are going to continue the class. So here today we learn about what is Maxwell's Betty's reciprocal theorem. Two theorems are there here. First is Maxwell's reciprocal theorem. So in any structure in its equilibrium, the deflection of any point A resulting from the application of a force at any other point B is equal to the magnitude to the corresponding deflection at B resulting from the application of a corresponding force at A. So to understand this, see what it says is, for any structure we are having 2 points A and B. Now if you apply the load at A, you will be having deflection at A and deflection at B. Okay, so first we will apply load at A and we will see the deflection what is happening at B. And the second time, if we apply the same load W at B, and now we will see the deflection what is happening at A. So what the theorem says is W into Y2 is the deflection cause at B, is equal to the force into, what is the force at B? Force into the deflection caused at B because of load at A. This is what is W into Y2 is equal to W into Y1. I can say the other example here is same here, 2 points A and B. First we are applying load at A. So because of load at A, we will have deflection at A and B, but we will calculate the load at B. And second time, load is applied, same load is applied at point B, and we see the deflection at A. So the relation is W into Y2 is equal to W into Y1. This is the Maxwell's reciprocal theorem. Now we are having one more theorem, Maxwell's Betty's reciprocal theorem. Here what it says is that work done by the set of forces P through a displacement produced by the set of forces Q is equal to the work done by the set of forces Q through the displacement produced by the set of forces P. See, you can understand with the example here. For example, if we are having one simply supported beam, we have points A, B. The force is P1 and P2. Now this is the displacement. We are having one more point C and point D. Now deflection at C, deflection at D, we have put it as delta 1, delta 2. Now next case, we are having one more set of forces Q1, we are applying at C, D. This is Q2, this is Q1. Because of Q1, Q2, we have again deflection shape. Now we will calculate the deflection at A, deflection at B. So this is delta 1, delta 2. So what Maxwell's Betty's theorem says is P1 delta 1 plus P2 delta 2 is equal to this into this one, Q1 delta 1 plus Q2 delta 2. See, this is the symbol for Q1, this is a symbol for deflection when P1, P2 is applied. So this is delta. This is the Maxwell's Betty's reciprocal theorem. So we cannot expect a long question here. We can expect a short question only here. Till now I didn't see any long question in the university exam. So one problem will solve here. See here, two set of forces. One first set of forces is 30 kilonewton and 50 kilonewton. When we are applied, we can see the deflection 7 mm at O. Now the beam shown here is carries load 30 kilonewton, 50 kilonewton at points M and N respectively to produce deflection of 7 mm at point O. Compute the load at O, which would produce the deflection of 10 mm and 8 mm at M and N respectively using Maxwell's-Bettis theorem. Now when we apply, let this be delta 1, this is delta 2. Now what is our formula? Says 30 into what is delta 1 given, produce deflection of 7 mm, deflection of 10 mm and 8 mm, 10 mm and 8 mm. This is delta 1 is equal to 10, delta 2 is equal to 8. So according to the formula, you have 30 into 10 plus this is 50 into 8 will give W into 7. From this we have to calculate W. W is equal to 300 plus 900 by 7. 300 plus 400, 700 by 7, 100 kilonewton. This is how we use Maxwell's-Bettis theorem. Now we'll start the second part of the unit, which is statically indeterminate structure. First of all, we will understand what is statically indeterminacy. Indeterminate structure is the structure which we cannot solve, the structure which cannot be solved by equilibrium equations. What are equilibrium equations? Sigma fx, comma sigma fy and sigma m. Using these three equations we cannot solve, so we need additional equations to based on compatibility. So first of all, we will understand what are the static indeterminacy. Static indeterminacy means, so what is the degree of indeterminacy? Means, for example, we are having external indeterminacy and internal indeterminacy. External indeterminacy is caused by supports. Internal indeterminacy is caused by members. Here, see, for example, we are having this structure. Here we are having three reactions. Here one, total 4 unknowns. Our equations are 3. The degree of static indeterminacy external, be it DSE, will become 4 minus 3 is equal to 1. 1 is the static degree of static indeterminacy. Likewise, if we have frame, so you have 3 reactions here, 3 here. Total unknowns are 3 plus 3, 6. So degree of static indeterminacy is 6 minus 3, 3. So 3 is the degree of static indeterminacy. Likewise, many structures we can draw. You can find out hinge, 3 unknowns. This is 2 reactions. So 5 minus 3 equal to 2. So all these are because of external indeterminacy. Now, if I have a structure like this frame, here I have hinge support, here also hinge support. The hinge means 2 unknowns here, 2 unknowns here. The total is 4 minus 3 will become 1. So this is also an indeterminate structure if you have hinge here and also hinge here. What problems you have solved previously using Castigliano's first theorem is, one we are having hinge, other we were having roller support. For hinge support we are having 2 reactions. If it is roller support, we have only 1 reaction. But if you have again hinge here, you have 2 here. 2 plus 2 will become 4. So DSE will become 1. So these are the static indeterminate structures because of external indeterminacy. Coming to internal indeterminacy, this is coming because of members. For example, you have structure like this. Structure like this, you have this member. Now here for trusses, what we have is M should be equal to 2j minus 3. Now here we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. Members are 9. Joints 1, 2, 3, 4, 5, 6. 6 to the 12 minus 3. Now M is equal to 2j minus 3, 9 is equal to 9. So if this is satisfied, this is statically determinate structure. Now if we go for indeterminate structure internally, so this structure is internally determinate structure. Now if you go for one more structure like this, this is hinge, this is roller. One member is like this, other member is like this. Now if you see here, you have joints 1, 2, 3, 4. 4 joint members 1, 2, 3, 4, 5, 6. 6 is equal to 2 into 4 minus 3. 8 minus 3 is 5. So static indeterminacy internal is equal to 6 minus 5 is equal to 1. So this is an indeterminate structure which is internally indeterminate. Internally indeterminate. So what is the condition is, your M minus 2j plus 3 should be equal to 0. Then it is determinate. Otherwise dsi will become m minus 2j plus 3 here. One more structure we will take. Hinge support, roller support. Now here joints here 1 2 3 4 5 6, and the members is 1 2 3 4 5 6 7 8 9 10. So dsi is equal to 10 minus 2 into 6 plus 3, 13 minus 12 1. Statically indeterminate by 1 degree. So in this unit, next part we will be solving this type of indeterminate structure using Castigliano's second theorem. Coming to the theorem, it states that the redundant reaction of a statically indeterminate structure is low as to make the total strain energy a minimum. It is also called as least work or theorem of minimum strain energy. What means? So if you have indeterminate structure, if you do the partial differentiation of the total strain energy with respect to the redundant, so that is minimum. That is, if you are doing partial differentiation with respect to your redundant force, that will become minimum. So we will use this. So we have some derivation for this. How we are going to apply using this in the trusses. For example, if we have now this truss we are going to analyze. Hinge support, roller support. So we are having this here, this here. Now we just now have done your static indeterminacy here will be 1. So what we do is A, B, C. First step is, that is we cannot solve this using equilibrium equations because your members are more. So what we have to do, first step is we have to remove one member or one reaction. One member when statically for internal indeterminate. One reaction when external indeterminate. Now here your external indeterminacy is dSE is equal to 0 because 2 plus 1 is 3 minus 3 is equal to 0. Internal is 1. So we have to, for internal indeterminacy, we have to remove one member. If it is external indeterminate, we have to remove one reaction. Okay. So first we will remove one. For example, we will remove one member. A, B, C, D. One member will remove. We have removed D, B. We have removed. So once we have removed D, B, we got this. This is statically determinate structure. Now we will solve this structure and find forces P in all members. That in all the members we will be finding forces. Next step is what we have to do for the stream structure. Remove external forces and apply unit tension force in the removed member. We called it as redundant member. So what we have removed? We have removed dB. This A, B, C, D. We have to apply unit tension force in the removed member. This is in this member. We have to apply unit force. This force is 1, and we have to find forces in all members. Applying unit force in this redundant member and find all the forces because of this. Like this we will do in this tabular column. See, this is the force P because of external force. External forces in determinate structure. U is the unit force in all the members. L is the length of the member. Now we will multiply PUL by AE. This is the column. And next column is U square. U is unit load. L by AE. Then R, your redundant force will become, if AE is common, we have to do summation for this one and summation for this one. PUL by summation U square L. This we will be getting R. This is the redundant force. With this redundant forces, we will find the actual force. P is equal to the actual force will be P is this force plus redundant force into unit force. This will be the actual forces in the members. So we'll start the problem. So this is the problem. Here it is hinge, it is roller support. So external static interdependency ds, first we will do internal. ESI is equal to m minus 2j plus 3. M is 1, 2, 3, 4. Just now we have done this. 6. 1, 2, 3, 4, 5, 6. Minus 2j. 1, 2, 3, 4. 4 to the 8. Plus 3. 9 minus 8 is equal to 1. Your internal DSI is equal to 1. External, you have 2 reactions here, 1 reaction here. So 3 minus 3 will become 0. So externally we don't have indeterminacy. Indeterminacy is because of internal only. So the first step is we have to remove the one member, because only we are If you are having 5 here, then it will be redundant. But because 6 members are there, so we have to remove one member. So we will remove one member. So first step is we have to find all the forces because of external force for statically determinate structure. So when you take reactions, this is RT. So you have here we have 4 meter. Theta will be 45 degrees. So RD into 4 is equal to 10 into 4. RD is equal to 10 kilonewton. See, if this is 10, so you will be having, this will be 10. And here downwards it is 10, so upwards also will be 10. Two reactions are coming because this is hinge one reaction because it is roller support. So we'll start the problem with, you can see joint C. And C, turn C, this is B and this is D. Sigma V is equal to 0, 10 plus FCB is equal to FCB. So FCB is equal to 10 kilonewtons. CB, BCCB is 10 kilonewtons. And sigma H is equal to 0. FCD is equal to 0. FCD is 0. So we'll go for the next joint. Joint D. This is 10. This is towards C, B, A. So you have 10 plus F DC plus F dB cos theta. FDC is 0. So FDB is equal to minus 10 by cos theta 1 by root 2 become root 2 minus 10 root 2. FDB is minus 10 root 2. Likewise, sigma V is equal to 0. FDB sin theta plus FDA is equal to 0 FDA is equal to minus FDB sine theta. FDB is minus of minus 10 root 2 1 by root 2 become plus 10 FDA. Next we go for joint B. Joint B is away from joint B, C, this is D, this is A. We want this one, so we go for FBA plus FBD cos theta is equal to 0. FBA is equal to minus FBD cos theta, where FBD is minus 10 root 2 minus 10 root 2 1 by root 2. Again it is plus 10 BA. Here AC we don't have, remember it is 0. So next what we have to do is, next step is to apply this is, we are applying away from the 1 kilometer. This is A, C, B, D. In AC we are applying 1, already known. Because of this 1, what is happening to all the forces we have to find out. So coming to joint C here, again here, we go vertical, FBC plus this is FAC or CA sine theta is equal to 0. FCA is equal to 1. So FBC is equal to minus of 1 by root 2. So it is minus 1 by root 2 FBC. FBC is minus 1 by root 2. This is sigma V. Now we go for sigma H is equal to 0. FCA cos theta plus FCD is equal to 0. So FCD is equal to FCA minus 1 by root 2. Minus 1 by root 2, again FCD. We got this one, this all the forces. Joint B. So you have like this. C A this is D. Now sigma V is equal to 0, FBC plus FBD sin theta is equal to 0. FBD is equal to minus FBC. FBC is FBC plus FBD sin theta. We want FBD. FBD is equal to minus FBC by sin theta. What is FBC? Minus 1 by root 2. Minus into minus. Minus 1 by root 2. 1 by root 2. So we have 1. FBD is equal to 1. We got sigma h is equal to 0. FBA plus FBD cos theta is equal to 0. FBA is equal to minus FBD cos FBD is 1. When you go that side, it will become minus 1 by root 2. FBA is equal to minus 1 by root 2. In the same way, we go for joint D. Away from joint, away from joint, away from joint. And this is C, B, A, D. We want DA. FDA plus FDB sin theta is equal to 0. FDA is equal to minus DB. DB is 1 by sin root 2. 1 by root 2. FDA is minus root 2. Again minus 1 by root 2. This we got. Now lengths. Each length AB is 4 meter. Everything is BC is 4 meter, CD is 4 meter, DA is 4 meter, DB. So DB will become 4 meter, 4 meter. This is D, this is B. Sin theta is equal to 4 by hypotenuse. Hypotenuse is equal to 4 by 1 by root 2 will become 4 root 2. Here dB is equal to 4 root 2. 4 root 2, 4 root 2. Now what we have to do? PUL. PUL. Multiply this by AE. AE. Here area and Young's modulus is not given, means that area for all the members and Young's modulus for all the members is same. So we will take this into this into this. So what we get? 40 minus 40 by root 2. Again minus 40 by root 2. This will become 0 minus 40 by root 2 minus 40 into 2 will become 80. This will become 0. This is u square L by A. U square is this one, is this is u square into this one, and 4 by 2 it become 2. Again this by this into 2, 2 here again, here also 2 again. This will become u square by u square into L. This will become 4 root 2, and this will become 4 root 2. So now what we have to do is we have to add all these things, this and this. So now we have to find the actual forces here. P is 10, R we got as 8.54, 8 this plus 8.454 into this one minus 1 by root 2. When we do this, we will be getting 3.96. Here also we get 3.96. 8 minus 6.04, and we get 3.96 again, minus 5.6, and we get, see here, P is 0 here, and multiply with 8.54, we get 8.54. These are all in kilonewton. This is how we do the calculation for all the forces using Castigliano's second theorem. Castigliano's second theorem is used for indeterminate structures. So the next problem. See, this is the problem. Again, we have to first find out statically degree of statical indeterminacy. Here members are 1, 2, 3, 4, 5, 6, 7, 8. 8 joints are 1, 2, 3, 4, 5 plus 3. So you have 8 plus 3. 11 minus 10, 1. You have 1 internally indeterminate structure. So externally we can see one hinge is one support, one ring roller support is there. Therefore 2 plus 1, 3, 3 minus 3 will become external indeterminacy is 0 here. So to start the problem, we have to select one member. We will select CB as the member. Same procedure you have to follow. Here external force given here is 20 kilonewton. Because of 20 kilonewton, we have to find out all the forces in the members. So we will find reactions. This is 4 meter, this is 3 meters, this is 3 meter. So this is RE. So RE into 4, and this is this direction, this is this direction. 20 into 3. So RE is equal to 50. Yeah, 15 kilonewtons. If this is 15, so you should have here this direction 15, and this is 20 down, so you should have here 20 up. You can start from any joint. Let us take this joint E. So you have this force. Now here we calculate sin theta. Sin theta is equal to opposite by hypotenuse. If this is theta, opposite is 4, hypotenuse is 5, because this is 3, this is 4, then this will become 5 by Pythagoras theorem. So sin theta is equal to 4 by 5. Cos theta is equal to 3 by 5. So wherever sin theta, cos theta will be there, we will put 4 by 5, 3 by 5. So joint E, this one is 15. Away from joint, away from joint. 15 plus this is E, this is D, this is B. FED this plus this plus this, FED plus FEB. EB, you have sin theta is equal to 0. Now here if ED is unknown and EB also unknown, this we have done by sigma h is equal to 0. So first we will go for sigma v is equal to 0. So here having only one downward force, this is FEB sin theta is equal to 0. Therefore FEB is equal to 0. Now if you put this here, this is cos theta. FED will become minus 15. FEB FEB is equal to FEB we got 0 and FED as minus 15. Okay. This is our joint E is over. Likewise we can go for joint B. So you have here 20 kilonewton downwards, away from joint, which is 0. This is also away from joint, This is B, this is E, this is D, and this is A. Now this is 0, so 20 is equal to FBD. FBD is equal to 20. Now sigma h is equal to 0, so you have this and this. F B A, this is 0, so again F B A will also become 0. Joint B is over. Now we'll go for joint D. Away from joint, away from joint, away from joint, away from joint. This is D, this is E, B, A and C. So in this, we know this one, we know this one. We go for sigma V is equal to 0. FDB plus FDA sine theta is equal to 0. FDA is equal to minus FDB by sine theta. Let's enter dB. dB is equal to 20 minus 20 by sine theta is equal to 4 by 5. 4 into 5. 100 by 4 is equal to minus 25. Minus 25. Sigma h is equal to 0. So you have F DC plus FDE FDC minus FDE plus FDA cos theta is equal to 0. So FDC we don't know. FDC is equal to FDE minus FDA cos theta. So FDE is equal to minus 15. DA is equal to minus 25 plus 25. Cos theta is equal to 3 by 5. 3 by 5, which will become 5 3s are 15 minus 15. So FDC will become 0. AC and BC are remaining. AC and BC. We know we have removed this one, so here BC will become 0, and again in this joint C, if I take joint C, C D, this is 0. Sigma V is equal to 0. FCA is equal to 0. FCA is equal to 0. This is how we calculate all the forces. In the similar manner, next step is we will apply unit force the redundant. This is the redundant. Now after applying the unit load at CB, we have to find out all the forces in the member. So here we got all the forces. This is the forces because of unit load in the redundant, and then we have multiplied this P U L by A is common here, again U square L. So we have to do summation for this one and this one. So when we do the summation minus minus, it is becoming 189, and this is coming to 7. And this is coming to 17.28. So here R is equal to minus 189 by 17.28. It's coming to 10.94. Now we have to find the actual force here. P plus R U. R is this one, P is this one, and this is U1. If we do this, we will get the actual forces in the member. So when we do, we'll be getting minus 8.75, 6.56, minus 15, 0, 11.25, minus 6.56, minus 14.06, 10.94.